Populations can also evolve through the introduction of novel genotypes into the population by migration. This is called gene flow, or simply the movement of alleles. There's an allele called the CCR5 del32 mutation that confers resistance to HIV. The distribution of this allele is thought to mimic the Viking migration through Northern Europe. Today, the highest incidences of the CCR5 del32 mutation occur in areas where selective pressure from the HIV virus is not that great. This illustrates for us that mutations do not arise on demand. If they did, we would expect to see a higher rate of this mutation in areas where HIV pressure was greatest. The ultimate source of this genetic variation, upon which natural selection acts, is mutation. Mutations are changes to the base pair sequence of genetic material. We talk about mutations as being random, rare, and recurring. They are also the rule, not an exception. All individuals are vulnerable to the effects of random mutations. Recombination introduces variation as well. During meiosis, new combinations of genes are created because alleles are shuffled and combined with other alleles from a mate's chromosomes. Sometimes these new combinations will make the individual better adapted to the environment.
You see, Mary and Tommy, in evolution, the things that fit in the best survive and have offspring.
Mr. Sanders, does that mean my parents are the best because they survived and had me?
No, Tommy, I've met your parents, and I'm guessing that had more to do with some type of cheap alcoholic beverage.
But, Mr. Sanders, what about the things that don't fit in?
Those things often die in horrifyingly bloody encounters with their predators as they shriek for help in their little animal voices.
Gee, that doesn't sound fair.
Perhaps not, Tommy, but that's not your problem, is it? That's evolution. As the saying goes, nature has her bad designs eaten by her good ones.